right, so we've dealt with simple ionic compounds. We feel good about that. The metal is empty of any electrons. The non-metal is going to be full. Okay, that's metal, non-metal. But what happens when we're dealing with non-metal, non-metal? Remember, they are sharing electrons, not transferring them. So this target, if given a molecule, I can draw its dot diagram. 3 rules. Number 1, add up the total number of electrons in the molecule. Just find them on the periodic table. What column are they in? That's how many outer shell electrons you have. Add them up. Number 2, set them up as symmetrically as possible. And I'll explain that to you here. Okay? You need to connect them with a pair of electrons, which will eventually become a dash. Number 3, arrange the remaining electrons in such a way that everyone has 8, except for hydrogen, who will be happy with 2. All right, here we go. First up, water. I need a volunteer. Thank you, Phoebe. How many outer shell electrons does hydrogen have?
1.
Times plus oxygen.
6.
2 plus 6. So we have 8 electrons to place. Okay, did you ever play monkey in the middle when you were a kid?
Yeah.
Okay, so it was like the person, okay, so who's the monkey in the middle? Who's the one that always goes in the middle? Well, hydrogen is never the monkey in the middle. So everyone else is potentially a monkey. Usually it's the one you only have one of. The one you only have one of is a big clue that that's the monkey. So the monkey in this case will have to be oxygen. We connect them to the hydrogen using a pair of electrons. A pair of electrons. Now, because it's going to get really tiresome using pairs of electrons, these are called shared pairs, a shared pair of electrons. It would be best if we could connect the dots together to form a dash. So a dash represents 2 electrons. A dash represents 2 electrons. Yes. Okay, so, yes. Yes. Phoebe, we have placed 4 out of our 8 electrons. So normally I would ask you to start placing the other 4 symmetrically going from the outside in. But in this case, the hydrogens are done. They only need 2. They have 2. Okay? The one that they own and the one that they're sharing with oxygen. So all we have left is to place 4 more electrons, this time around oxygen. 2, 4, count with me by 8s, by 2s, please. 2, 4.
6.
Phoebe, and okay. Before you leave it, ask yourself, have I placed all the electrons I had? Yes. Does everyone have 8 except for hydrogen, who's going to be happy with 2? 2, 2, 4, 6, 8, 2. Done. All right, Natalie. Carbon. How many?
No, that's an
Wait.
I.
Oh, that's an I.
Yes.
Oh. Carbon. Wait, isn't it? 6.
Nope. Try again.
7.
Nope. Try again.
4.
Yes. Very good. 4. It's in the 4th column, therefore 4, not in the 6th column. And that would be 6. All right. Iodine. How many?
9.
Try again.
7.
Yes. Remember, we're just counting the number of what column it's in. That's how many outer shell electrons we have. But there are 4 of them. So it's 7 times 4. So while I answer Morgan's question, you can take out your calculator and calculate 4 plus 7 times 4. Yes, Morgan.
So the first number is from whatever the charge is on it.
No. What column is it in? It's in the 4th column. What column is it in? It's in the 7th column. All right, Natalie, what is 7 times 4?
32. No, 28.
Plus 4 more?
32.
So we have 32 electrons to place. Now, in this case, it's pretty easy because you only have one of carbon. Okay, but let me tell you a little bit about carbon. Was there always a kid that when you played monkey in the middle with, you always stuck him in the middle first? Yeah. We called him the ultimate monkey, right? That was you? Okay, you're carbon. You are the ultimate monkey. Carbon is the ultimate monkey. If you have two of them that you only have one of, and you're debating, should I use carbon or should I use the other one? No, use carbon. Carbon is the ultimate monkey. Carbon always goes in the middle. All right? I. We connect them together using a dash. A dash represents how many electrons?
2.
All right, Natalie, count with me.
2, 4, 6, 8.
Now start on the outside and work your way in.
10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32.
Done! Yay! You've put up all the electrons. Is everyone happy? Let's see. Natalie, count.
Oh, 2, 4, 6, 8.
That iodine's happy.
2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8.
Everyone's happy. Congratulations. You have drawn a dot diagram. PCL3, volunteer. Okay. Mark, go.
All right.
P, how many?
5,
CL,
7,
7 times 3
21,
plus 5.
26.
Who's in the middle? Who's in the middle?
P.
Do you want to be a left, right, bottom kind of guy or a left, right, top kind of guy?
Let's do left, right, bottom.
All right.
It's easier.
Count.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26.
Done. We've put up all our electrons. Is everyone happy? 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. All right. Congratulations. Mark, you have drawn a dot diagram. Any questions? Thank you, Sasquatch, for being technical. Morgan, thank you for volunteering. Carbon, how many?
4.
Oxygen,
6, and then times 2. So that's 6.
who's in the middle? Who's in the middle? Count with me. You have a hard time counting by twos?
The dot, like when you,
Okay, we have to put 16 of them. Ready?
oh, okay, yeah. So 1,
Well, no. A dash is
0. Oh,
2.
yeah. So 2 and then 2 and then
Okay, count by twos, please. 2, 4.
6, 8, 10.
Okay, don't do the middle. Do the outside first.
12, 14, and then 2 on the top of the right?
No, you go on the outside, work your way in. 16! Yay! Morgan, you placed them all. Yay! Now let's make sure that everyone is happy. You ready?
But carbon's not happy.
Hush! Morgan's doing this. Morgan. Let's count. Say 2.
2, 4, 8,
Yay!
10, 12.
No. We're checking to make sure that everyone has 8, except for hydrogen, which only needs 2.
Okay, we're good. Yay.
Yay! And this one?
That's 4.
Morgan, by chance, you got the hard one. All right, so we're going to make believe you're carbon, and Alec is the oxygen, and Simon is the other oxygen. Okay, so we hear blubbering coming on because, I mean, she's already close to tears as it is. So she's going, and pretty soon the water starts coming down the eyes, and then the water starts coming down the nose, and then the most disgusting and yet fascinating thing I have ever seen happen. It only seems to happen with little kids. Snot bubbles coming out. You know what I'm talking about?
No.
That is both disgusting and strangely fascinating.
It's so
Okay, especially when they're breathing in and out, you can see it, you know. That is fascinating. So, we see snot bubbles coming out of Morgan, and Alec is beginning to feel sorry for her. Alec, let's review. You are sharing 2 electrons with Morgan, and then you have 6 unshared pairs just sitting there doing nothing. And she's there crying because she only has control of 4. Aww, couldn't you do something for her? Give her some of the things. By things you mean a pair of electrons. Yes! Very good. Oh, that was very generous of you, Alec. Nice job. Now turn to her and let's see what she says. Give her a pair and let's see. Oh, she says, no, it's not enough. I need 2 more. So she turns to Simon. Turn to Simon.
Hey, Simon.
Hi. Do a snot bubble at him. I need 2 more. Ooh, nice snot bubble. Now you're on YouTube. Okay, so Simon, she would like for you to do the same thing Alec did and give up 2 electrons. Oh, he did. Congratulations.
What about our electrons, man? Now we're not happy.
No, you've got 8. 2, 4, 6, 8. 2, 4, 6, 8. These are called double bonds. Double bonds. What? Yes, you have to share them in pairs. Double bonds, and turn that frown upside down.
But then they don't have that.
No, yeah, they do. 2, 4, 6, 8.
That's so cool.
So, that's called a double bond. All right? But, is that the only possible structure? What if? See, what were we assuming? That Simon was going to also be generous. So, what if Alec decides to be generous, but Simon looks at her and says, no. Oh, try again. Try again, Morgan. Ask him again. Ask him sweetly and nicely.
Hey, Simon, can I?
No.
Okay.
Okay. Well, you're going to have to try Alec again because you're not happy.
Hey, Alec, can I have some electrons?
We want me to say it for the sake of this video.
Yeah.
Yeah, sure.
Thank you, Alec. You're finally getting the gist that I need to go somewhere with this, and you oftentimes you don't respond well. Okay. What do we call that? A triple bond. Okay. Can you have a quadruple bond? No. Triple is it. Triple is it. Triple is it. So the question is, who is really CO2? Is it this one?
Yeah, that one.
And it depends on what kind of...
Or is it this one?
This chemistry, like if you're using...
Wait, what was the question?
Does it matter?
Actually, it does. This could influence the way it acts. So they used a scanning tunneling electron microscope in order to figure out whether it really was 2 double bonds or a triple bond, and this is what they found. They found a bump for O, a bump for C, and a bump for the other O. And that proved that it was double bonds.
Yeah.
Okay, why? Because what they had learned is that the more bonds there are between atoms, the closer the atoms get. So if it had been a triple bond, then it would have been O, C, other O. Triple bond. It would have been unevenly distributed. Oh. Because they were evenly distributed, then they came to the conclusion that it was two double bonds.
So what would it mean if it is triple bond, or would
If it was triple bond, then it would mean that the molecule could resonate. What does it mean to resonate? Let me give you an example. Okay, we're looking for molecules that exhibit resonance. SO2. Mortal. Sulfur, how many?
He called him mortal.
Oxygen, how many? Times? Who's in the middle? How many electrons have I already placed? Let's start counting them. All right, Mr. Morta, is everyone happy? Who's not happy? Okay, so what does that mean? If you place all your electrons and somebody still doesn't have 8, what do you now have? What tool do you now have in your arsenal?
Double bond.
Double bonds. Okay, who are you going to double bond with? The one on the left or the one on the right? The left.
Why not both? Because then you would have.
Because then you would not have as many electrons. Okay, no, that's a common question. I'm glad you asked that question. If you did 2 double bonds, then all you would need is 16, but you have 18. Okay, so they started asking, does it really matter? Could it have been this one? So once again, they started playing around with the technology that we have, and what they found out is that 50% of them were like this, and 50% of them were like this.
Well, the other way around.
Yes, but what they did is they tagged these things, one being radioactive and the other one not.
How can it one be radioactive?
I don't understand how they did it. They came to the conclusion that the answer to the question of which one was it, left or right, was neither and both. What they think is going on, hey, it's chemistry. This can happen in chemistry. If you want it not to happen, just go on over to physics, where they have every rule, they have no exceptions to the rule. For us, it's fun because I give you a rule and then I tell you all the different exceptions to the rule. Isn't that fun? Okay, stop. Does anyone here have a piano at home? A real piano. Okay, you. How often is that piano tuned? Okay, then you don't have a piano, you have furniture. How often is that piano tuned?
Probably, I want to say my dad tunes it like every 3 months or so.
Wow, it usually just needs to be tuned once a year.
He's pretty good.
Okay, so what does he use? So your dad tunes it. What does he use?
A tuning fork.
He uses tuning forks. So a tuner is going to come in with these boxes of these tuning forks with 2 tines. Yes. Ding! And the tines are going to vibrate back and forth, making the sounds at different frequencies in order for the tuner to adjust the wiring so that the wires are giving the right sound. Okay, the key thing is you can even though they have 2 tines, you can no longer see them when they're vibrating back and forth. They are said to be resonating. A fan has 4 blades, but after you get it going, it's resonating so fast that it looks like it's just one blade, right? Thank you, Ryan. All right. So what they think is actually happening is that this double bond is resonating back and forth so that when you take a picture of them, half of them are going to be resonating to the left, the other half is going to be resonating to the right.
So cool.
Back and forth, back and forth, back and forth.
You had someone on both sides, you're like, here, no, here, no.
Right. So if I take pictures, half the time it's going to be with her, and the other half is going to be with you. Yes.
So then what makes it radioactive?
No, that's how they were tagged. I don't know. It had something to do with. They were able to prove that it was 50-50 using a mechanism that I don't quite understand. How about that?
Alright.
Okay. All right. So that is resonance. Gang, I said all that to say that whenever you draw one of these things and you have a single bond and a double bond, you need to recognize that it can resonate. CO2, can CO2 resonate?
No.
No, why not?
It has 2 double bonds.
It has 2 double bonds. Go, Alec.
How many times does it go back and forth? Like a second?
A bunch.
Who knows? Infinite.
This many.
I don't know.
I don't.
Yes.
Okay, for CO2, when it has the triple bonds, then.
If it did have a triple bond, then it could resonate. Very good, Phoebe. All right? We're done.